we use both the acoustic nature of the conversation to understand sort of the general context, but also we use the words. So we use traditional speech-to-text systems as well to understand what is said. And it's really the combination of the tone and the words that actually, so we call it the acoustic and the semantic nature or aspects of the conversation that give you a full understanding of what exactly is going on.
Nico Perony, welcome to the Voicebot podcast.
Hey, Brett, it's good to see you again.
Really good to see you. This has been a long time in coming, and I think we have a lot of really interesting things to talk about. One of the things that we should probably orient around is that you're at Unity now, but a lot of people in the voice AI community will know you as the co-founder and CTO of Otto. Or is it Otto? How do we say this?
Just Otto. I don't know that a lot of people actually know this, but if a few people know this, it's great. And yeah, you're right. So we say Otto, some people say Otto. And the fun thing is that we didn't know, but the name actually means sound in Japanese. I learned this after we'd founded the company and named it, that Otto, I don't know if my pronunciation is correct, but Otto means sound in Japanese. So this is a third and accepted pronunciation for a company that is no more anyway, because we're Unity now.
That's right. You were acquired by Unity a few years ago. So let me ask you about the origin behind Otto. What were you trying to accomplish originally?
It's interesting. We got together. I've always been interested in interactions. I come from a background of merging engineering, a bit of biology and sociology. My PhD was actually about, understanding how people interact to form society, really. And I always found communication incredibly interesting because it's just so like what we can do with language is incredibly deep, right? Language is at the basis of everything that we do, everything that's around us, right? And I had always noticed that computers were not able to deeply understand human conversations, animal conversations either, but it's a different topic. We can talk about dot communications too, etc. But let's stick to humans for a bit. And so what we set out to do really was to introduce empathy in the understanding that computers can have of human conversations, in a sense that back when we started Otto in 2017, we had speech recognition systems, right? You could talk to a computer and the computer would produce tokens and that reflected what you said, but never how you said it. And so when we're speaking now, and when you listen to me, when you try to understand, how I feel, what I'm actually thinking, what I mean when I say a certain thing. If I say, "Hey, Brett," or "Hey, Brett," these are going to be two different things, yet the transcription in a normal speech recognition system is the same, just "Hey, Brett," these two tokens, right, with no nuance to them. And so what we set out to do was build systems, machine learning, artificial intelligence systems that could decipher the true meaning of human conversations and bring these to digital systems. So that was really the bigger mission. Now, pragmatically, what we also did was work with and in call centers in order to better, to improve the understanding of customer satisfaction, NPS, etc. And we did a bunch of different things, going from, robots to healthcare, to animals, actually, and eventually gaming. And we found, so I'm sort of skipping to the end of the story, but we found out in 2021 that a really good use case for the technology that we built, technology is still called deep tone, because it brings a deep learning understanding of the tone of a conversation. We found that bringing an AI into every chat room, in a way, could be formidably useful to make online conversations better. The biggest problem that multiplayer games have nowadays, and the leading cause for churn, is that people are just not really nice. People are not very kind to each other. And so you hear a lot of words that are said, and in ways also that they are said that are just not okay. And you can't put a human moderator, a community manager in every chat room. So what we realized is that we could take the technology that we had an API and we have an SDK, and it could run really fast. So it was pretty cheap to run at scale. We realized that we could put this technology, so the acoustic understanding of a conversation, put this technology and bundle it with a voice communication system. Unity has Vivox, which is one of the leading voice com systems in the world, and essentially just make online conversations more civilized. So this is really the story of Auto, like sort of 5 years of history, packed in a few minutes. But we went from a big idea to a bunch of different use cases that for which where we try to apply the tech, and eventually something that actually did work quite well. And it's become Safe Voice. Safe Voice is an internal name. I don't know if when we actually go to market fully, the name will be retained, but we are now in alpha. It's bundled with Vivox at Unity, and I couldn't be prouder to bring this technology and the ability to have better conversations to millions now and hundreds of millions soon of players worldwide.
Well, when I was first introduced to Otto, I really liked, you had this one page where you could just basically just upload audio, and it would process. I don't remember how long it was, but less than a minute.
Mm-hmm.
And then, and I think you might have truncated the files or something like that if they were longer, but it would then just start to go through, and you could actually, it would do labels, and it would basically do
Yeah.
like color coding of sentiment at different points, and you'd sort of click play, and then you'd sort of go through there, and it would say, excited, angry. I don't remember what the sentiments were, but there were a few different things in there. And I thought it was really fascinating. I didn't think it was always right, because what I would do is I would just upload my podcast and or a portion of my podcast, and I would just see like, what is this? And I would listen to it. But in a lot of ways, it didn't matter, because there was no way to consistently or algorithmically identify sentiment
Mm-hmm.
in an audio file that was like easily accessible. And so I just thought it was fascinating that it was doing that. And some of it was clearly right. And maybe it's mostly right. I don't remember like on the data sets that you were, because this was a generalized model and I'm just throwing like a random podcast up there. But I thought it filled a gap in the market that I heard IBM talking about, that I heard a lot of people mentioning,
Mm-hmm.
but nobody was demonstrating it. Nobody showed that it actually worked.
And it's interesting because you're right, we did this, and yes, it did drive quite a bit of traffic, and we got great feedback. And it was actually instrumental in some of the inbound interest that we had towards an acquisition. People say, "Wow, everyone talks about it, but you're actually amongst the very few who can show it." And so that was good. On the other hand, like you said, it didn't always work. And I think I'm fine with saying this today. AI, machine learning, we used a fully supervised approach, and machine learning is only as good as the data that goes into the system. And we had very good models, very lightweight, very fast, very well optimized, etc. But ultimately, like you say, an emotion is very subjective. You wouldn't know how I actually feel now. And you can have an idea based on my facial expressions and the tone of my voice, of course, and what I say, and maybe what you know about me, etc. But you won't know how I feel. So if someone tells you you're angry, you have every right to say, "That's not true, I'm not angry." And then maybe you get angry by saying that, I don't know. But essentially, we built, so Deep Tone is a language agnostic way of recognizing the nuances of intonation, including emotion. And of course, sometimes it's say, "Well, you sound really excited then in this bit of the conversation," and actually you're not that excited. Or it say, "You sound angry," and well, anger is something that is very subjective and hard to assess. But of course, it made mistakes, and that's fine, because the aim of the system is not to say, "We know that you're angry," with a 97% confidence. but it's to say, hey, this conversation is likely to contain harmful content, harmful, because we detected a tone that is characteristic of verbal aggression. So would a community manager, would a human review this conversation? Would a human look at that? Because there's 10 community managers in a large community and 1 million conversations that come in every day. And there's no way that humans can look at this, like can review all of the conversations, right? So what we want to do and what we're doing with Say Voice is putting AI at the service of human intelligence. So really combining what AI can do best, which is sifting through vast amounts of data, in this case, audio data, and surfacing those samples, those conversations, which are more likely to contain some problematic content, but then the human makes the decision.
Are you doing this from tone alone, or are you also running a transcription and then looking at the words or the entities or the semantics?
It's a combination of both. We use both the acoustic nature of the conversation to understand sort of the general context, but also we use the words. So we use traditional speech to text systems as well to understand what is said. And it's really the combination of the tone and the words that actually, so we call it the acoustic and the semantic nature or aspects of the conversation that give you a full understanding of what exactly is going on.
Got it. And so you have a generalized model for what do you call it? Safe tone or something like that, or deep tone?
Say Voice. Deep tone is the tech, and Say Voice is the internal name.
Okay, so I want to talk about deep tone for a second. So you have like a generalized model for that. Have you found that the generalized model works as well as you need it to for these use cases, or do you need to actually customize it in each implementation?
That's interesting. We made the decision early on. We trained custom models for different customers and different use cases, and we quickly found that this wasn't really scalable because then you go into a more of a services business. And so what we did is that we focused on building models that were broadly good enough for most use cases, all the while being also clear about their potential limitations and also exposing not just the raw decision values, but confidence levels, etc., the different classes that were detected in a bit of audio. And so I found that this is probably the most scalable and most powerful way to deploy AI systems, to have one model that runs well everywhere, but also document its limitations. Say it's been trained on this data or this kind of data, so it's likely that if you evaluate it on another kind of data, it can be another language. We had a project where a customer used our models on Arabic conversations, and our models had never heard Arabic, right? And so we discovered that everything sounded angry, if I remember correctly. Simply because I wouldn't understand Arabic. I wouldn't understand if someone is actually getting angry in a conversation. So it's a bit the same. And I think that as long as you document fairly, we talk about model cards nowadays in AI. You document fairly and transparently what a model does, what it's been trained on, its limitations, how to counteract bias in the model, etc. Then you're usually fine. And this is where the community is headed today, and that makes me quite happy.
Yeah. So does this mean then you need to develop a new model for each language?
So with Auto and Deep Tone specifically, we made the conscious decision to not do that, to develop a language agnostic model that only relied on the tone of the conversation, such that imagine that you're hearing an argument behind closed doors. You can only hear sort of the muffled sound, the tone of the conversation, but you can't really understand the words, right? So this is really what Deep Tone does, is to capture the acoustic context of the conversation to give it a meaning. And then systems like Say Voice for to curb online toxicity pair this acoustic detector with a semantic capability, so basically speech to text, in order to build a fuller understanding of the conversation, and that is language dependent.
Got it. And that semantic model is also a general model. So it's general model by language, but not by customer, for example.
And that's correct. That's
Yeah.
correct. We use models that are language specific, but not necessarily customized for every single deployment.
Yeah. And that goes back to your scalability comment earlier.
Yes, yes, yes. I'm just thinking because there's well, now we're part of a much larger company. There's public and private roadmaps, and there's many things that I'm not completely at liberty to
Okay.
talk about.
Fair enough.
And when we go into the specific details of safe voice deployments, customers, etc., I have to be a little careful and say, I wouldn't know about that.
Yeah. Fair.
Maybe I would. Maybe I would.
Maybe you would. Well, so, and I want to get more into Unity, and this CEO of Unity just had an interview and talked about some of your plans going forward. But before we go there, you mentioned complex systems earlier, and I'm wondering how complex systems has influenced the way you came to this market.
To the market of deciphering interactions, communication, you mean?
Yeah, when you were thinking
Okay.
about Otto, how do you think you maybe approach this differently because of your background in complex systems and someone who just had a standard electrical engineering background, which I think you also have?
Mhm. Yes, yes. I have a background as a robotics engineer, so building small robots. And then at some point, I realized that nothing was working, and nature was doing it much better. So I went into behavioral biology to try and understand how animals do things and solve problems. And I realized that they tend to solve problems much better when they work together. So that led me into collective behavior, which is an application of complex systems. So essentially understanding how different individuals, agents work together or interact in order to create an emergent behavior. And that emergent behavior may be problem solving. So that is really complex systems. And to your question, how did this perspective, how was it factored in the auto approach? So much of an important tool in the complex systems toolbox is graph theory, right? Looking at nodes and vertices, edges between the nodes to represent interactions. And I remember that quite early on in the approach that we had to understanding conversations, especially multi-partite conversations, we'd build and I would build graph-based models to fully capture sort of the higher order nature of the conversation. I'm not saying it worked very well always, because often there's information that's missing, etc. But I know that it informed my thinking, and it was quite important. It was quite unique in the way that we approach this. Understanding conversations.
Yeah, that's interesting too. Now, you've been named recently the director of AI research at Unity. So maybe we can build on this a little bit. So you could talk about what the scope of that is, but I'm also interested when you start thinking more broadly around AI, particularly around generative AI, which is like the topic we're going to get to in just a moment. Does your background in complex systems and graph theory, does it influence that area maybe as well?
Oh yeah, of course. Complex systems teaches you to think sort of in the abstract about the interaction between different components of a system. And machine learning is really about this. First, a neural network, when it's trained, there's some very interesting parallels between neural networks and complex systems, because neural networks can be shown to be super critical when they're trained in a given way. So essentially, they exhibit properties in the way that their nodes, the virtual neurons, arrange, which are reminiscent of things like power grids, for example. And I could talk about this all day. But there's some interesting parallels simply because the abstraction is the same. It is a neural network is a graph. But beyond this, I think something that you learn as a systems person really, is to think about, so in the abstract, how different components of a system interact, how we can, move them around, remove some, etc., to produce a given behavior. And when you build AI systems and distributed systems broadly, this is what you need to do. Okay, what's going to happen when we scale from 1x to 10x and 1000x. How should we distribute the load in order for the system to respond to a spike? How is that encoder going to cope with data that comes in a different format, a different structure, etc. So and that is helped. That kind of thinking is helped when you think in systems terms.
Well, the one thing about complex systems too is the rise of unintended consequences.
You call them unintended, I call them emergent, but you're right. Oh yes, and something that we see as a side comment, something that we see that is incredibly interesting, but also I suppose in a way it is a little scary, is that large language models, the likes of GPT and Palm and Flan, etc., Llama recently tend to exhibit emergent behaviors, tend to exhibit properties that appear with scale, such that you train a neural network, and up until a certain size, a certain number of parameters, typically in the billions, so these are really large networks, they can't do something really well. They can't have elementary world reasoning, they can't follow an object in a conversation, for example. And then at some point, that property emerges. It goes from being non-existent to actually being present in the system. And so that brings about a ton of questions, such as, what happens? Like, do these scaling laws, do they apply to much larger network sizes? What happens if we keep throwing, and this is what, OpenAI and DeepMind, etc., are doing. What happens if you keep throwing more compute and more data at the problem? What is the next emergent property? I don't know. No one knows, to be fair. But it's an interesting question.
Well, the one that people are familiar with the large language models is hallucinations. So, and that might be on the downside because it's like making things up. But I was looking at something, I think it was in technology, MIT Technology Review recently, where there are some other potentially benefits, emergent behaviors that are unintended consequences, but they're essentially new features. Right. And so, some of the things that people are thinking about potentially for critical reasoning could be emergent at the right level. And it seems to be apparently that there's new points in the vector database that just like show up that actually are not hallucinations. And to the extent that they're wrong, maybe it's the same type of emergent phenomenon, but they actually provide something that gives you truth.
So let me say this here. People talk about hallucinations. I like the word. I don't have a problem with it. As if they were a problem. And of course, if you ask a factual question to an LLM and it gives you a wrong answer, then it's not okay. But fundamentally, LLMs are not made to spit out facts. They're made at the lowest level. They're trained to predict the next token. So they are trained to identify statistical regularities in text at a very large scale, at a scale so large that we humans cannot comprehend it. And so one question that I like to ask language models to test them is, how many helicopters can a human eat in one sitting? And a model that is not trained very well, or that is too small, is going to say, well, typically 2.5 helicopters, but be careful because eating too much can be unhealthy, etc. It's a hallucination in a way, because no human has ever eaten 2.5 helicopters in one sitting. That is not in a training data, but that corresponds to something that a human could say, the kind of pattern that a human could produce in a similar conversation. So this is what I wanted to say. Language models are not trained to produce facts. They are trained to approximate some amount of reasoning about the world, and reasoning that can be captured by simply the next word in a sequence. So it's incredibly crude in terms of approximating intelligence. And so the fact that they can actually talk about stuff and and state facts is a byproduct of the entire training scheme. They're not made for that. And so if you want a language model to do search, we call it generative search, what you need to do is pair it with a structured knowledge base and knowledge graph,
Mhm.
which is what a ton of companies are doing these days, which is what Bing AI is doing. It says, hey, I'm going to look up this topic on Bing, and it reads facts, and then it can tell you this is what I found. But the knowledge that is embedded in the weights during the training of the neural network is not necessarily sufficient to answer a factual question, and it should not be considered sufficient anyway.
Yeah. So yeah, they hit a retrieval model. Retrieval model pulls back what it thinks are the sources, and then the LLM works on the
Yeah.
sources to generate the response. And that is interesting. I like your point here that hallucinations may not be a bad thing. What they do is they reflect some sort of reality of the data that the model was trained
Yeah.
on, and therefore probably reflect some sort of reality that is present in the world today.
Hmm. That's correct. So if you ask a language model, write prose in the style of author X, there's going to be no hallucination. When I write a poem, which hasn't happened in a while, I do hallucinate about the world. I put words together in a way that they kind of make sense and maybe kind of not as well, but they sound good. Or the reading is pleasant, and so the whole thing is a hallucination. And so this is why, as a parallel, language models tend to work well when they are asked to be creative, to generate text on a given thing. Um, whereas for facts, they typically need to be paired with a structured knowledge source.
Which is interesting too, because the use cases that are getting the most traction right now, or the most interest, the hype around them, are actually use cases that we tend to want to be deterministic. And if you think about search, that's one of those. We want the facts. That's like our expectation. We talk about the call center, which is very interested in a lot of these features. They want to make sure there's some control over what they're delivering. They don't want to provide incorrect product information to a user. And there are all sorts of creative pursuits as well that are using this, but they're not getting as much
Mhm.
hype as some of these other areas that have maybe direct business and monetary activity associated with them.
So I don't know about this. If you look at companies like is it Copy AI,
Sure.
Jasper,
Yeah.
uh, they have built businesses that look scalable and fairly robust on the ability for language models to generate text in a creative manner, right?
Yes.
And so there's other companies like U.com and Bing, of course, etc., that base their value proposition on the search aspect or use case, but it's not the only one by far. And if you look at other use cases such as image generation, video generation, etc., these are really in the creative domain. So I'd say right now what we see is a healthy balance. I mean, it's a very new world. The fact that these models work so well is incredibly new. I didn't expect it to happen so fast. And so I think everyone is kind of trying to adjust to what this new technology can do.
Yeah, I think it is interesting. So obviously, if we look at image generation, that's been revolutionary. Midjourney came out last week and is another step up in terms of quality. And yeah, absolutely, Jasper, Copy, those companies are, from the AI writing assistant standpoint. Grammarly's got some new solutions now. There's WordTune. And these things are tremendous, and it
Hmm.
provides that step in between. It's not like a runtime activity. So the author can then go in and check for veracity of the statements. They can do all these other types of things. But it is really like it's fascinating to me that we have these things like search, with call center, interactions with customers. We have code generation, another key use case in this
Yeah.
space, and those all have place a premium on control, consistency, veracity.
Yes.
And so then all the work is to saying, oh geez, the productivity improvements are amazing. How can we then add new tools on top to do some sort of validation?
Absolutely. Validation and artistic control. So I think we're going to talk about Unity in a bit, but of course, generative AI is a big deal. That's the understatement of the year. I suppose, for Unity as
Well, let's
well.
talk about that.
Um,
Let's talk about Unity. Go for
let,
it.
us talk about this. Um, there, there isn't a world in which a game designer goes from, working for months and years on end on their game before releasing it, where we go to, there isn't a world where we go from that to a game designer that says, I want a game with spaceships and lasers on an alien planet, and the player should have 3 lives, right? And types it, or just speaks it into a computer, and then a computer just churns out a game, and the game corresponds to the vision of the game designer, game developer, etc. That just doesn't exist. In the same way that you don't create a painting by just describing it. And if you're creating something with, say, you talked about Midjourney, right? The process, you see these beautiful images online, but for those that actually look good and correspond to the original vision of the artist, this very tedious, painstaking process of structuring prompts and reusing bits and blobs from other prompts in order to come iteratively to something that actually resembles, reflects the vision of the artist. And the interface is still clunky, like text prompts are not the best way to do that. And so something that I can't say much about what we're doing internally with generative AI at Unity again, but obviously it's a big deal. And we have a whole bunch of people working on a number of use cases. And something that is important for me as an individual and for Unity as a company is to allow our users to get value from these new tools, all the while retaining artistic control in their workflows. We want to make artists and game designers and game developers, we want to make them faster, we want to make them more powerful, but we also want to make sure that they remain in control of what they do. It's not the machine making a game, it's still them.
You're right. So let's talk about what your CEO said yesterday. And this will be a few days ago when people like watch this video, but it's recent, right? Let's say we're talking about March 2023. So Reuters reported a teaser video from Unity showed such software could allow developers to type text such as add 2 seconds of thunder or make them flying alien mushrooms and have the video game's assets or code auto-generated rather than needing to design from scratch.
Mm-hmm.
So this is interesting. I think it's similar to what Roblox said it's going to be bringing to the market as well not too long ago. But this idea that we get into not a low code platform, but a no code environment potentially for anybody to be able to create games. And it might be interesting for me to understand like what's the difference between saying this and creating an object in Unity.
Yeah. Um, so what you described and what you quoted JR, our CEO, is one aspect of injecting generative AI broadly in the game design process. Yes, you do want to interact with natural language, with systems, expert systems, software that is complicated to use. I mean, let's face it, right? Unity is by far the most popular game development engine, especially for indie developers, but it's still complex. There's still a steep learning curve, and we have resources online to help people get onboarded and learn, etc. But it's still hard. So what we want to do is provide ways to our users, regardless of their proficiency level, give them ways to be faster and more efficient in their use of the tool. And that can be just, a simple natural language interface. Make me a game, that's a bit extreme. But why not? Make me a game. Or generate an asset. You say 2 seconds of thunder. A big element of the value proposition of Unity for developers is the asset store. The asset store has millions of 2D, 3D assets, sounds, animation packs, etc., which make it much faster for a developer to actually build a game, because they can just reuse other components that people have built before, created before. Yet much of that content is kind of buried, and it's also it's difficult to find, etc. So you'd want an AI that can surface just the right asset for you. And from there, you want to you want to allow the AI to create an asset, right? To go from, there's the storm recording and there's maybe a bit of thunder, but without the storm, and you want them both. And you can either do it manually in a tedious sound design process in this sound effect example, or you can use the AI to say, hey, with inspiration from this and that, give me this sound effect, 2 seconds of thunder, the way it would sound if it were heard from a cave, because my game is staged in a cave, for example. So this is something that you want to do. But then that doesn't stop there. There's underneath it, there's all this code. You talk about Roblox. What they demoed yesterday and released is also a code generation solution.
Right.
What you describe as a no-code solution is actually a model that generates code, right? And so Unity uses C#, and C# it's not a very hard language to learn, but it's still a programming language, and it has formal syntax, etc. And there's tons of people out there who don't want to learn it, who don't want to bother, writing actual computer code. And so we need systems that are going to be able to manipulate assets directly. I want to say, hey, here's a game object. I want you to change its texture or its its shape, rotation, whatever. But I also want to say, now I want you to generate code such that this tank rotates its turret by 35 degrees every 15 seconds, for example. And that is going to be turned into a bit of code, a bit of a script that is going to apply to a game object. And so what you describe as a no-code solution is more of a new way of interacting with a software system that is formidably complex to the point of being daunting at times, and making it easier for a user to create things, assets and behaviors and effects in a game, all the while retaining, again, this artistic control.
Yeah, I think one of the really interesting things about this is you think about a game being a multimedia space with procedures that need to be written in order for it to operate. And generally, the people who have skills in 3D modeling to create objects and images that are interesting are not the same people that are actually going to be writing the procedures and know the C# syntax and those types of things. So it's the opportunity for the developer, the C# developer, to create objects quickly. And maybe that's the final object. Maybe that's all they need for their game, or maybe it's just they're doing a prototype and that gets them far enough. But also enables the designer to create some fun objects and then automatically generate the procedures that will execute the game.
Exactly. We want to enable more capabilities in our users. I'll tell you what drew me to generative AI in the first place, so modern generative AI, because I like to say machine learning has been generative for a long time. We've long had models that can generate, sequences of output sequences, but now they just have become very good across a range of modalities, etc. So generative AI it is. And so slightly over a year ago, I started using the very first public version of Midjourney, and I started using Stable Diffusion also before it was released, etc. And I was like, that's amazing. It's going to change everything. And the reason for this is that I consider myself a creative person in a way, because I can think of things. I can think of images and concepts, and I've been composing music in my head for a really long time, but no one's ever heard it because I can't play music and I can't write music, right? And so there's always been a very long distance, an infinite distance between a concept in my head and the same concept thought on paper on a screen. And so I took to writing actual text. I like to write fiction, or computer code. I like to write computer code because that's one way I can express my creativity. But I was never able to paint or actually make music. And I found that generative AI made me able to draw in a way that I had never been able to before. And it's the same for music. And I think it's a good example, as good an analogy for, like you say, a game developer who knows code, but is going to have to work directly with an artist. And before they work with an artist, they might want to generate concept art and give it to them to represent their approach to the game design process. And so my goal is to make our users more versatile, to more powerful in the range of abilities that they have inside of the Unity editor.
Yeah, absolutely. Okay, so I think that's fascinating. I think this is going to touch so many areas. Gaming, it's certainly in gaming, but beyond gaming as well. And we're already seeing some of that. There was another comment that your CEO JR made that I thought was interesting in this Reuters interview. In every video game in history, the dialogue was written by somebody. But
Mm.
now what you can do with generative AI is give these characters motivation, personality, and objectives, and then they can spawn dialogue that doesn't require a writer.
Oh, that's a very good comment, and it's something that I may or may not be working on. Um, but yes, you're
Well,
right.
it's out
So
there in the public. Your CEO talked about it.
it's never been possible to have a true deep interaction in a game with an NPC. Usually, you
Yes.
go and they talk about a quest, but you can't ask them what they ate yesterday. You can't ask them about. You can't talk to them about anything that concerns you. They are rarely context aware. They don't really know what is happening in the game. If you give them a specific object, they won't necessarily be able to react to it, etc. So they have limited conversational abilities. And of course, it's now possible to interact with a potential NPC in a way that ChatGPT allows you to have, a Q&A, a question and answer
Mhm.
process with something that resembles or approximates some level of intelligence. So what happens if you take that ability and you constrain it such that it can only talk as if it were a cowboy, for example, in 19th century California, say, and it has a personality. There's some background story to it or them, and it can talk about this, but you also constrain the so you sandbox the model in a way that it can't talk about, say, COVID-19, for example.
Right.
What happens when you do this? Can you do this in a way that it serves the user experience in the game? I think so. Can you do it in a way that you also mitigate potential bias and harm that could come from the language model? Can you do it in a way that it runs in real time on an embedded device, for example? Do you need the cloud? What happens when the model fails? Can you do it in a way that it serves a given quest? Because ultimately, you want the NPC to give you a key to go and open that treasure chest somewhere, right? So how can you weave all of these different elements into sort of a new definition of what an NPC is in a game? Is a very interesting problem. And if I were to work on something in the direction, it would probably be this.
Yeah, well, it's really interesting too. So we think about the different models that people can employ. So uh, ChatGTP, just like generic ChatGTP or GPT-4 can have a conversation with you.
Yeah.
You can also prime it, prime your prompts to have information about the backstory or what the character knows, the time frame that they live, and those things. You can create some constraints there. The downside of that is that it might work for the session that you're in, but it won't have any memory. So the next time you interact with that NPC, it'll be starting from scratch again. And then there's something like what InWorld is doing, which I think is really interesting, where they're creating these profiles, which is sort of a mix of generative plus some guardrails, which could be safety guardrails, but also just, in many ways are just like personality consistency guardrails that they're generating. And this strikes me as a completely different in-game experience. Ultimately, if you have that, you have those personalities, you have this like natural, mostly natural human interaction type of conversation, but then it also has some memory, like session to session, has like across your account as well, and it knows its past interactions with you. This is completely different than what we've had to date.
Yeah, So memory is interesting because when you talk to, say, ChatGPT, you're right. So the session is reinitialized every time. It's like you speak with a new agent every time. It doesn't have to be like that. So the natural, logical answer to needing memory is introducing some form of actual memory, like a database, and you store entire conversations in full form in the database. You can retrieve them, etc. But that's not how human conversations work. When I talk to you, it's not the first conversation we have. You'll have a faint memory of some of our interactions. There are some that you won't remember. There are some things that I will say that you will hear like as if it were the first time, but it's not, etc. So you have a faulty memory, and so it would be fair to say that after each conversation, it might be enough for someone, an agent, to write a summary of the conversation in a given form, and then append it to a list of summaries, which can itself be summarized after a certain time, etc. And that summary could be given as context to the language model in order to say, hey, this is what happened. GPT-4, for example, the larger version has 32,000 tokens of context. That's about 60 pages of text. So that's an awful lot of information that can be summarized in order to give the model context as to what it should take into account when generating the next answer. So it's a very long answer to the question of can we add memory of past interactions and context to an LLM-powered NPC? Sorry for all the acronyms. The answer is yes, and the technology that we have today already allows this.
And this is interesting too, because you talk about that context window that you can use to prime the prompt with additional context. We also have this concept of a retrieval model, so that
Mhm.
when you ask a question, it could actually look in the database, just like what we were talking about for search and the way that u.com or New Bing or Perplexity are working. It's basically looking at that data store, and that data store could be things about the character, like how they would speak. It could also be things about the interaction with the player, right? So it could pull those
Yep.
back. This idea though, that's like there's faint memory, is really interesting, and these summaries might be actually more human like, as opposed to the last time we met you said, and then like sort of, put that off. But this idea that you were talking about that you were injured, is your injury better or something like that?
Mhm.
And it strikes me that the optimal model probably is a mix of some sort of retrieval model or database. Maybe it's summaries, maybe it's actual conversations, and then the priming for the prompt and the context
Yeah.
window.
Yeah. And I mean, whether you need retrieval and information retrieval at all really depends on the depth of the personality for the NPC you're building. And then how do you implement that retrieval? Does the NPC say, "Ooh, I wouldn't know about this," and they go back into their house, let me look it up, they say, and they go back into their house and come back and say, I have the answer for you. So it's all about the feature set that you want to give the NPCs, um, and what kind of interaction you want to have with them. If you compare this to an actual human conversation, there are few instances in which someone will say, I don't know about this, but I'm going to have to look it up and I'll get back to you with an answer.
Yes.
Most conversations don't need that
Yeah.
because the context that we have in our heads is typically enough. And arguably, the context that modern language models have in their, I'm not going to say head, but the context that they are aware of is much, much broader than what we feeble humans could do.
So you have a background in conversational AI. You know a thing or two about natural language understanding. One of the things I ask a lot of people, and I'm just going to ask you as well, why are the large language models so much better than NLUs very often at divining intent without actually understanding intent, because they don't actually have that understanding?
Oh, Um, so I think it goes back to the idea of like emergent. You're talking about NLU systems that are trained to recognize intent on a variety of on a small data set of commands or something, and you compare this to modern language models. I would say so. It has a lot to do with the emergent properties of these models. The fact that a lot of the wealth of human knowledge, in a way, is embedded in their ways, but not only knowledge, but how it is accessed and how reasoning is performed. I'm not saying that the models reason, not necessarily, but at least they can approximate reasoning. And so, insofar as the information is present in a string of text, and the way that you want to access information about the string, for example, sentiment or intent, you were talking about NLU, intent recognition in NLU systems. Insofar as there are similar examples in the training set in sufficient quantity, and that is going to be the case for many problems, then you can think as large language models as just really, really big hammers that can hit many different kinds of nails. And so intent recognition is one of those nails.
Yeah, I think that's a really good way to think about it. And I think there's a lot of people who are trying to think through right now who have NLU based systems and that want to upgrade them. They're trying to decide what the role the LLM should have. And a lot of people are using the NLU just on the front end. And then
Mm-hmm.
they're handing something off to the LLM, and and the LLM might just generate the output, or the LLM might generate the output, and they might validate or review the data, compare it to a retrieval model, or the NLU might not go to the LLM because it divines the intent and it thinks it knows the answer, and it just goes to its standard deterministic response.
Mm-hmm.
But I think there's some other people who are thinking about this more creatively, and they're basically parallel processing. They're looking at it, they're going to send the request to both the NLU and to the LLM at the same time, and then do some analysis of the response and arbitrate which one is better.
Mm-hmm. Is that a question? Yes.
Well, actually, just a comment, because I'm seeing this out there, and like I'm interested in your feedback on that in terms of what you think of those different models where we are.
Yeah, look, it's going to depend on the use case. There will be product and engineering decisions. Typically, querying a large language model is expensive, can be slow. If you use a cloud system, so the advantages of using a local system have to do with cost, privacy, latency. And so if you need a system that is cheap to run and that doesn't send data to a third party or to a cloud server, ideally, and responds fast, there's three reasons why you would want to exclude an LLM, right? Today, they require large, very big GPUs or clusters of GPUs to do inference. And Llama, for example, so this new family of smaller language models goes towards single GPU deployment, etc. But it's still using an LLM is not without trade-offs. So depending on the experience that you want in your product, whether you can tolerate hallucinations, we talked about this, right? And exactly what resource envelope you're working in, then you may want to not use an LLM at all. And that's why I talked about product and engineering decisions.
Yeah, absolutely. Well, and it is really interesting because like very, very frequently people just totally ignore the cost element. And for example, GPT-4 just came out. People were really excited about it, and the standard context window for GPT-4 is 8,000 tokens, but they have the option to have the 32,000 context window for the tokens. I hear nobody talking about the fact that the 32,000, the API for the 32,000 context window is twice as expensive. It's twice as expensive for the input and for the output, and they have input and output differentiated pricing. But that means if you're using the API with the 32,000 context window, even if you only have a context, even if for an individual query, it only has 200 tokens in the context window or something like that, you're still paying twice the amount.
Exactly.
And in like, if you look at GPT-4 versus GPT 3.5, not Turbo, but the old Da Vinci model, that is that's going to be 50% more costly, and so like people aren't really thinking about this. They're saying, oh, I'm just going to add this LLM, and for your POC it doesn't matter because the numbers are all really low. But if you turn this on in a contact center, or you turn this on like in a game, like all of a sudden it gets very expensive very quickly to generate all those tokens.
Absolutely. And that's why there's tremendous power in this I'm showing my iPhone to the camera, and there's a lot of power, and all of the devices are sitting around us, and much of that power is unused often. So it would make sense to use an idling device some of the time at least to do inference and generate text, especially if it is for a problem where you don't necessarily need this really big hammer that we talked about. And maybe an NPC doesn't need to be that smart, or maybe an NLU, intent recognition system, doesn't need to be able to generalize to 80 different languages and the entirety of the possible context of conversations between any two humans. And so for all these reasons, you may want to look at a different approach to problem solving, and there's the cost, of course. So I think we should continue exploring prototyping with very large language models, and it's incredible, like the range of possibilities that are afforded by these models is breathtaking. Yeah, we should also stay reasonable and think of what makes sense for a given product, and then make engineering decisions based on that.
Absolutely. Okay, so let's close on just a comment that you made earlier, which was this moved much more quickly than you expected. And I think
Oh yeah,
that's not unusual, even for people who are right in the middle of it. Of course, we have other people like Jan LeCun saying, well, wait a second, these systems have been able to do this for a long time. So, maybe it's not that impressive. It's sort of out of context because he says it's impressive, but it's like people are just like recognizing what we saw 18 months ago. But I wonder if you think about, it moved very quickly. I mean, what has impressed you most? What is the most
yeah.
interesting thing that you've seen out there, or just keeps you cogitating overnight about
Okay.
what's happening?
So yeah, a couple of things. First, what Jan LeCun says is that he's been working on deep learning, or the precursor to deep learning, since the 80s. And so, of course, from his perspective, it's like, yeah, we've had these building blocks for a really long time, except we haven't been able to pair these building blocks, and also we didn't have, say, transformers until 2015 or something, 2017. And so we had the right building blocks, and we had the right approach, I guess, to solving these problems. We didn't have the compute, we didn't have the data. And so what is definitely new is the abilities that these models exhibit. And so that is really fascinating and impressive. And to my point and your question about the pace of development, yeah, this has really, really surprised me. I've been working in and on technology for give or take 20 years soon. And I've always been seen as a hyper optimist, someone who always sort of tends to overestimate how fast we'll get to a given level of performance, which has caused quite a few frictional discussions with my co-founder when we were building Goto, because it was like, oh, that's fine, we're going to solve this in a month, and 3 months later it still wasn't there, etc. What has been different? It's been different for the past year as I followed the rise of multimodal generative systems, and I keep revising my assumptions. First it was on a monthly basis, now it's on a weekly basis. My assumptions as to what foundation models can do. To give you an idea, we're looking at ways to generate 3D assets, of course, at the moment, just out of curiosity, of course. And so the literature, the state of the art on the generation of 3D shapes and meshes, etc., changes literally on a weekly basis. It makes it poses an interesting challenge for a research team or product team to decide on an acceptable solution for a given problem, and it forces us and me to think of team structure in a different way. The challenge becomes not how to find the best solution for a problem, but how to structure a team such that it can iterate on the advances, progress in technology that is happening out there in a way that we can capitalize on the latest things. And so I would say that is the first time in my short career that I'm facing this problem. It's a great problem to have because it's better to have technology that moves almost too fast than too slowly. And yes, for me, it is a very new sort of paradigm to think in.
I wonder if part of the issue has been in the past, we've relied entirely on humans to implement some of these new features. And so some intersection of the humans and the technology trying to bring it to commercialization, let's say, or the
Hmm.
application as opposed to core research. We've been doing all this work for a long time, core research around AI, and it's basically had a lot of potential energy
Hmm.
because all this research is getting better and better and better. But there hasn't been a lot of focused effort on the application of that technology. And so all of a sudden, what we're doing is we have the application of the technology, people are coming in, and there's fewer barriers there to actually roll things out quickly. And we're really just
Yeah,
harnessing this potential energy because it's essentially an automated output.
absolutely. So, and what liberates that energy is the fact that more and more of these, models or building blocks um, are not only usable by everyone, but also now open source more and more, so that
Yes.
everyone can use them and fine tune them and tweak them, etc. And so the power of the community here is incredible. So that's one. Um, what was the question again? I'm sorry.
Well, I just wonder, it was
Oh,
really just,
yes, you're right. Automation of improvement. Sorry, I want to say. And then what is new? You talk about the human involvement. What is new is that it is now possible to, in some cases, use AI systems to improve AI systems. And I'll
yes.
take the example of the alpaca paper from Stanford. So essentially, it is taking a llama model, so an open source language model, and then fine tuning it in a way that, in the same similar way to what OpenAI did to go from GPT to instruct GPT, so fine tuning it on an instruction data set. But the interesting thing is, the instruction data set that is used by Alpaca was actually generated by GPT. It's something like 50,000
Yes.
instructions or Q&A pairs. And so the way the model went from, predicting the next token to being better able to follow instructions was by using a synthetic data source that was generated by another AI model. And I think this is telling for what is happening at the moment. We have people in the community that are able to patch together different components and sample them and leverage already existing AI blocks in order to build better functioning and more powerful systems. And so that is really, it's an exciting time to be working in AI.
100% agree. Nico, how can the viewers and listeners find out more about what Unity is doing, keep track of what you're doing in your research in the AI lab?
Okay, well, we have some interesting announcements coming around Unity strategy, around AI and generative AI. We'll be we'll be saying much more in the near future. For now, what you can do is also go to unity.com. Also check out Unity Labs, which is the R&D division, to understand what's been done until now. And rest assured that we'll be showing some exciting and really cool stuff very soon.
Awesome. All right, folks, I'm Brett Kinsella, host of the Voicebot podcast. Thanks a lot for joining us again today. And thank you, Nico, for taking so much
Thank you, Brett.
time and talking about your background, your history in the space. Congratulations again on that great acquisition by Unity and some of the cool things you're doing in the AI lab. Great to talk to you again.